Welcome. In this upcoming conversation, we will embark on a deep dive into cloud infrastructure. We will be exploring OpenStack, which is described as a powerful open-source platform for building and managing clouds. We will cover its core components and aim to understand how these components interact and manage data flow. This conversation will aim to provide a comprehensive understanding of OpenStack, specifically through the lens of Canonical's contributions and their valuable tools like Juju and MAAS.
Ever feel like getting your head around cloud infrastructure is, I don't know, like trying to decipher an alien language?
Yeah, I can feel that way sometimes.
We're here to translate. Welcome to the deep dive. Today, we're cracking open OpenStack.
Right.
Think of it as a master set of blueprints, sort of, for building your own cloud environments, tailored exactly how you need them.
Exactly. And we've gathered some really insightful material for you to help make sense of it all.
Okay.
We've got a pretty comprehensive look at OpenStack's design, how it's put together. Plus, info straight from Canonical. They're a key company, really involved in OpenStack.
Canonical, right.
And we'll look at their powerful automation tools, Juju and MAAS. They're pretty central to Canonical's approach.
Okay, so the mission for you listening today, we want you to walk away with a clear understanding of what OpenStack is all about, why it's, a significant player in the cloud space, especially when you stack it up against other options out there.
Yeah, the comparisons are important.
And how Canonical specifically makes using it maybe a bit more manageable. We're aiming for those aha moments, right? Without getting totally bogged down in like super technical jargon.
Absolutely. Let's step through the noise a bit.
Okay, let's unpack this then. So in simple terms, maybe starting there, what is OpenStack? Okay.
So at its core, OpenStack is basically an open source platform. It's for building and running clouds.
Open source, okay.
Yeah, and it actually started back in 2010. It was a collaboration between NASA and Rackspace.
NASA, interesting.
Yeah, they wanted a more open approach to cloud computing. And what's fascinating is how it's just grown since then. It's now this massive project driven by a whole global community of developers and users.
Community driven, that sounds important. So it's not controlled by just one big company then?
Precisely. That's a key point.
Yeah.
It operates under an open source license, which means anyone can use it, change it, share it freely.
Oh, wow.
And that really fuels a lot of innovation. Plus, it helps you avoid being locked into one provider's specific tech and their pricing.
Right, that lock-in factor.
Exactly. Its main goals, its principles, are really about being scalable so it can grow with demand, flexible, adapted to what you need, and extensible so you can add new bits later on.
Scalable, flexible, extensible. Got it. And practically speaking, what can you actually do with it? What are people using OpenStack for?
Well, all sorts of cloud setups, really. You can build private clouds, inside your own data centers for internal stuff, public clouds accessible to, the public, and hybrid clouds mixing your own gear with public cloud resources.
Oh, okay.
It handles creating and managing virtual servers. That's compute virtualization, setting up and securing virtual networks, providing storage space.
So the core cloud functions.
The core functions, yeah. And even supporting bigger things like big data processing.
Okay, sounds like a pretty versatile toolkit. But why would an organization actually choose OpenStack? What's so what? What's the core appeal?
Yeah, good question. There are several key business reasons. One big one can be cost savings. Especially when you compare it to some proprietary cloud solutions out there.
Right, the cost.
You also get a lot more control over your entire infrastructure. That's huge for companies with specific security or compliance needs.
Control, okay.
Then there's avoiding that vendor lock-in we mentioned again. You're not tied to one company's roadmap or price hikes.
Makes sense.
Plus, being open source, you benefit from all that community-driven innovation. It moves fast.
How does OpenStack compare to something maybe more familiar, like a traditional server virtualization, like VMware, maybe?
Right. So traditional virtualization, running multiple VMs on one physical box, that's definitely part of what OpenStack does. It uses that technology.
Okay.
But OpenStack is much broader. It's not just about making VMs. It's a complete cloud management system.
Okay. The bigger picture.
Exactly. Think of it like this. With virtualization, you're managing individual servers, maybe groups of them. With OpenStack, you're managing your entire data center as this pool of resources.
A pool of resources.
Yeah, the users can tap into on demand. Self-service portals, automated processes. Yeah. It orchestrates the whole thing.
Gotcha. And what about the big public clouds? AWS, Azure, Google Cloud. When would someone pick OpenStack instead of going with one of them?
That often comes down to keeping things in-house or on premises. With OpenStack, you host it on your hardware.
Right.
So you have much greater control over where your data physically sits. That's critical for data sovereignty rules or, really specific security policies.
Data location, yeah. That's a big deal for some industries.
Huge. It also lets you use hardware you might already own, leverage those existing investments. And it's really key for hybrid cloud strategies. You can mix your own private OpenStack cloud with public cloud resources when it makes sense.
So flexibility again.
Exactly.
Yeah.
We see this a lot in industries with very specific, often strict requirements.
Like who? Can you give us some concrete examples?
Sure. Telcos, the telecommunications companies, they're using it heavily for something called NFV network functions virtualization.
NFV, okay.
It lets them manage their network services like firewalls and routers as software on standard hardware. Much more flexible, more efficient.
Interesting.
Big enterprises often build private OpenStack clouds for their internal apps, maybe sensitive data they want to keep close.
Right.
And in academia and research, you see it used for building powerful research clouds, giving computing power to students, scientists.
Okay, so OpenStack is this open source project, but you mentioned distributions. It sounds like there are different ways to actually, get it and run it. What are these flavors?
You're right. So the foundation is what's called Community OpenStack. That's the upstream project where all the cutting edge development happens.
The raw code, basically.
Kind of, yeah.
Yeah.
But deploying and managing that directly can be, pretty challenging, complex. That's where distributions come in. Think of them as prepackaged, tested, and often commercially supported versions of OpenStack.
Ah, like Linux distribution.
Exactly like Linux distributions. Good analogy. Some of the major ones are Canonical's Ubuntu OpenStack, Red Hat OpenStack Platform, Mirantis has one, SUSE has one.
And what makes them different? Why choose one over another?
The main differences were usually things like the underlying operating system they prefer, Canonical, naturally builds on Ubuntu.
Makes sense.
They also differ in the management tools they bundle in, the level of commercial support you can buy, how often they release updates, and any specific integrations or, performance tuning they've done.
Okay.
And for our chat today, it's really worth highlighting Canonical's strong focus on their tools, Juju and Implications. That's a big part of their offering.
Right, Juju and AS. Which leads us nicely to Canonical OpenStack. What's their specific angle? What makes their approach stand out?
Well, Canonical is a really significant player in the whole OpenStack world. They contribute a lot back to the main project. And their focus has really been on making OpenStack more accessible, easier to operate, especially through their distribution built on Ubuntu. Natural.
Which is good.
Definitely. Their core strength, you could say, is providing this stable, well-integrated OpenStack platform that works hand in glove with those automation tools we mentioned, Juju and MAAS.
All right, Juju and MAAS. We keep hearing these names. Let's really dig in now. What exactly is Juju?
Okay, Juju. It's what they call a model-driven orchestration tool.
Model-driven orchestration.
Okay. Yeah, think of it as a way to define like a blueprint for how your applications and services should be set up and how they connect to each other. You model your application architecture.
A blueprint for apps.
Exactly. And the really clever part is this concept they call charms.
Charms, like Lucky Charms.
Not quite. Think of them more like reusable packages of automation knowledge, expertise captured in code.
Okay.
Each charm contains all the instructions needed to deploy an application, configure it, manage it throughout its whole life, set up, updates, scaling, connecting it to other things.
So instead of manually scripting everything, you use a charm, and it knows how to deploy, say, a database.
Precisely. It encapsulates all that operational logic.
Yeah.
And what's really neat is that Juju thinks about the relationships between applications right from the start.
Relationships, how so?
So if you deploy, say, WordPress using a charm and MySQL using another charm, Juju understands that WordPress needs a database. You tell Juju to relate them, and it automates setting up the connection, the user, the permissions, all that complex integration stuff.
That sounds incredibly useful, connecting the dots automatically.
Exactly. It handles things like setting up monitoring for the application, maybe configuring single sign-on, connecting it to logging, all those cross-application dependencies.
And I think you mentioned it's not just for one type of environment.
That's right. That's another big plus. You can use the same Juju charms and models to automate your stuff, whether it's running on AWS, Azure, Google Cloud,
Okay.
or in Kubernetes containers, or on traditional virtual machines, or even directly on bare metal servers.
Wow, okay. So one way to manage apps everywhere.
Pretty much, yeah. A consistent approach across different infrastructures.
Yeah.
And there's a whole ecosystem built around this.
Tell me more. I think I saw something about CharmHub.
You did. CharmHub is essentially Canonical's curated marketplace for these charms.
A marketplace for automation.
Kind of, yeah.
Yeah.
The community partners, Canonical themselves, they share pre-built charms there. It's a massive resource. You can find charms for tons of software.
Like what?
Oh, loads. Popular databases like PostgreSQL, MySQL, MongoDB, big data tools like Kafka, Spark, AML platforms, and essential infrastructure stuff like Prometheus and Grafana for monitoring Kubernetes itself. It really speeds up deploying complex stacks.
That sounds like a genuine time saver.
Okay.
Now let's switch gears to the other tool, MAS. What problem does that one solve?
Right, MAS. It stands for Metal as a Service.
Metal as a service,
Yeah.
like infrastructure as a service, but for physical service.
Exactly. Its whole purpose is to let you treat the physical servers in your data center almost like they were virtual machines in the cloud. It automates the entire life cycle of your bare metal hardware.
Automating physical boxes. Okay, tell me more.
Imagine being able to provision a physical server, install an operating system on it, Windows, CentOS, ESXi, Ubuntu, whatever, remotely, through a nice web interface or an API, just like you'd spin up a VM in AWS. No need to physically go plug in a keyboard and monitor.
Okay, that takes away a lot of the manual grunt work, right? Racking servers is one thing, but configuring them all.
Exactly. It dramatically speeds up OS installation. MAS can automatically discover new servers when they're plugged into the network.
Oh, neat.
It can handle low-level stuff like BIOS or BMC configurations, manage network booting using PXE, provide DHCP, DNS, IP address management through APIs. It takes care of all that plumbing.
So it handles the network setup for the servers too.
Yep. And it even includes hardware testing features, so you can run checks to make sure servers are healthy before you deploy anything on them. That's handy.
And crucially, it integrates really well with other DevOps tools. Ansible, Chef, Puppet, and of course, Juju.
So MAS provisions the metal, and then Juju can deploy the software on top.
You got it. That's a very common pattern. MAS gets the base OS running. Juju takes over to deploy OpenStack itself or Kubernetes or other applications.
Okay. And I remember reading something about MAS creating KVM microclouds. What's that about?
Yeah, that's a cool feature. MAS can designate specific physical servers to act as KVM hypervisors.
KVM, the Linux virtualization.
Right. So MAS can then deploy and manage virtual machines directly on those designated physical servers. It essentially lets you create small, self-contained KVM clouds managed by MAS itself.
Why would you do that?
It's really useful in, say, edge computing scenarios. You might have a few servers at a remote site, and you need both bare metal for some tasks and VMs for others. MAS can manage both.
Oh, okay. Edge computing.
Or even in a larger data center, it can help optimize resource use, letting you allocate VMs or bare metal flexibly from the same pool of hardware, all managed by MAS. Interesting. So putting it all together, when we talk about charmed OpenStack, is that just deploying OpenStack using these Juju charms, probably with MS underneath?
Precisely. That's exactly what it means. Charmed OpenStack is the term Canonical uses for deploying and managing a full OpenStack cloud environment using Juju charms.
Okay.
It brings that consistent, model-driven, automated approach to the entire OpenStack deployment, initial setup, configuration, adding more nodes later, handling upgrades.
Upgrades can be tricky with OpenStack, I hear.
They historically have been, yes. That's one of the big areas where Canonical argues Juju really simplifies things, making upgrades more repeatable and less risky.
Okay, so Canonical's pitch is basically OpenStack's power and flexibility, but made significantly easier to deploy and manage day-to-day using Juju for the software and MS for the hardware.
That's a pretty good summary, yeah. Simplifying the operational complexity is a major focus for them.
All right, we've covered the what and the why and how Canonical tackles it. Let's maybe zoom out again and look under the hood at the general OpenStack architecture. What does it actually look like structurally?
Okay. So at a high level, OpenStack has what's called a modular architecture.
Modular, meaning lots of different pieces.
Exactly. It's made up of a collection of distinct services like building blocks. And these services all talk to each other using APIs, application programming interfaces.
Standard ways for them to communicate.
Right. And this modularity is a real strength because you can pick and choose. You only need to deploy the services you actually need for your specific cloud.
Okay.
A really fundamental split within this architecture is between the control plane and the data plane.
Control plane versus data plane. Okay, break that down for us.
Sure. The control plane is like the brains of the operation. It's where all the management and control of the cloud happens.
The management layer.
Yep. It includes services like Keystone, that's the identity service. It figures out who you are and what you're allowed to do.
Authentication and authorization.
Exactly. Then there are the API services for the core components.
Yeah.
The Nova API for compute requests, Neutron API for networking, Cinder API for storage, Glance API for images.
So all the entry points for requests.
Right. And also Horizon, which is the web dashboard, the GUI that users interact with. These control plane services handle all the requests, make scheduling decisions, talk to the database, orchestrate everything. But they don't usually run the actual user workloads themselves.
Okay, so they're the managers. Then the data plane must be.
The workers, exactly. The data plane is where your actual applications run, where your virtual machines live, where your data is stored and moved around.
The actual cloud resources.
Right. So this includes the Nova compute nodes. Those are the physical servers running the hypervisor software, like KVM, that actually host your VMs. It includes the Neutron agents running on commute nodes or dedicated network nodes, and the underlying network switching fabric, like Open vSwitch, that handles the actual network traffic.
Got it.
And it includes the Cinder storage backends, the actual storage systems, could be Ceph, NFS, SANs, where your persistent block data is written.
So control plane directs, data plane executes.
That's a good way to put it.
Yeah.
The control plane makes the decisions based on APIs and policies, and the data plane carries out those instructions using the physical resources.
Okay, that makes sense. Let's zoom in a bit on some of those core component names we heard. Nova, Neutron, Cinder, Glance, Keystone, Horizon. Can you give us just a quick, simple rundown of what each one's main job is?
Sure thing. Let's do a quick roll call.
Okay.
Nova, that's the main compute service. Think of it as the engine room. It creates, manages, and terminates virtual machines on demand. It talks to the hypervisors.
Got it. Nova VMs.
Neutron, that's networking. It provides network connectivity as a service between all the other bits. It lets you create virtual networks, subnets, routers, firewalls, security groups. It mixes everything up.
Neutron networks.
Cinder, that's block storage. It provides persistent block storage volumes. Think of them like virtual hard drives that you can attach to your VMs. The data stays, even if the VM is off.
Cinder virtual hard drives.
Glance, that's the image service. It's like a library or registry for your virtual machine images. These are the templates or blueprints you use to launch new VMs.
Glance VM templates.
Keystone, that's the identity service, acts like the security guard at the door. It handles authentication, who are you, and authorization, what can you do. It provides the user directory and manages API tokens.
Keystone security guard.
And Horizon, that's the dashboard. It's the web-based graphical user interface, GUI, that provides a way for administrators and users to interact with OpenStack services, launch VMs, manage storage, etc.
Horizon web interface.
Yeah.
Makes sense.
Those are generally considered the core 6 projects.
We also heard about Swift, Heat, and something called Ceilometer earlier. What about them?
Right, there are many other optional services. Swift is object storage, different from Cinder's block storage. Think Dropbox or S3 scalable storage for unstructured data, like backups, logs, media files, website assets.
Swift S3 like storage. Okay.
Heat is the orchestration service. It lets you define your infrastructure using templates, text files describing all the resources, VMs, networks, storage, and their relationships. Infrastructure as code for OpenStack.
Heat infrastructure as code.
And Ceilometer, or more broadly telemetry, that used to be the main project for collecting metrics about resource usage for monitoring and billing.
Used to be.
Yeah, its role has evolved. In newer OpenStack releases, the data collection is often handled by other agents, and the storage and alarming functions have moved into newer, more scalable projects like Nachi for metric storage and AID for alarming. But the overall function of telemetry remains crucial.
Okay, so monitoring and metering is still there, just handled differently now.
Exactly. More specialized tools have emerged.
So how do all these pieces actually work together? Say I go into Horizon and click Launch Instance. What happens behind the scenes? Briefly.
Okay, yeah, good example. So you click Launch in Horizon.
Yep.
Horizon talks to the Nova API saying, hey, this user wants a new VM with these specs and this image.
Okay.
Nova first checks with Keystone. Is this user legit? Are they allowed to create a VM? Do they have enough quota?
Keystone gives the thumbs up or down.
Right. Assuming it's okay, Nova then goes to Glance. I need a copy of this specific image. Glance provides the image location.
Got the template.
Then Nova talks to Neutron. Set up the networking for this new VM, give it an IP address, connect it to this network, apply these security rules.
Networking sorted.
If you requested persistent storage, Nova also talks to Cinder. Create a new volume of this size and attach it to the VM later.
Storage gets ready.
Then Nova's scheduler component figures out which physical compute node, running the hypervisor, is the best place to actually run this VM based on resource availability and policies.
Finds a home for the VM.
Yep. It tells the chosen Nova compute service on that physical server. Okay, create the VM using this image, attach this network, attach this storage. The hypervisor then does the actual work.
Wow. Okay. Lots of chatter between services.
Definitely. And a lot of this communication happens asynchronously using a message queue, typically RabbitMQ. It helps decouple the services. And the overall state, what VMs exist, network configs, etc., is stored in a central database, usually MySQL or MariaDB.
Okay, that paints a clearer picture of the internal dance. You mentioned supporting services and integrations. What else is important in the ecosystem?
Well, we touched on the database, MySQL, MariaDB, and the message queue, RabbitMQ. Those are pretty fundamental for OpenStack itself to operate.
Right, the plumbing.
On the networking side, while Neutron provides the framework, it often integrates with underlying software-defined networking SDN technologies. Open vSwitch, OVS, is very common. Calico is another popular one for advanced policy and routing.
So Neutron manages, but OVS or Calico do the actual network heavy lifting.
Often, yes. They provide the data plane implementation. OpenStack also supports various hypervisors, not just KVM. QEMU is related, but you can also integrate it with VMware vSphere, which is important for companies already invested in VMware.
Good point. Use existing VMware infrastructure.
Exactly. And for bare metal, as we discussed with Anis, the OpenStack project for that is called Ironic. It lets OpenStack provision physical machines just like VMs, often working with tools like MAAS underneath.
Ironic, managing the bare metal within OpenStack.
Got it. Now, thinking about actually deploying this, I assume you don't just run everything on one laptop. What are the typical setups and how do you make it reliable?
No, definitely not recommended for anything serious. The simplest setup is an all-in-one, where all the services run on a single server. Good for learning, quick tests, maybe small dev environments.
The lab setup.
Right. For any real production use, you absolutely need a multi-node architecture.
Spreading things out. Exactly. You distribute the OpenStack services across multiple physical servers, usually based on their roles. You'll have dedicated servers for the control plane services.
The brains.
Yep. Separate servers or groups of servers acting as compute nodes.
The muscle running the VMs.
Dedicated network nodes sometimes to handle routing and DHCP. And separate storage nodes providing the Cinder volumes or Swift object storage.
Okay, specialized roles. And reliability. High availability, or HA.
Crucial for production. You need to build in redundancy at multiple levels to avoid single points of failure.
Makes sense. How do you do that?
Well, for the control plane, you typically run multiple instances of the key services like the APIs, the scheduler, the database access behind a load balancer.
So if one API server dies, traffic goes to another.
Exactly. You also need a highly available database cluster, usually 3 or more nodes, so the central state isn't lost if one database server fails.
Okay, redundant control and database. What about network and storage?
For networking, you want redundant physical network paths, maybe using bonded network interfaces on the servers. You might have multiple Neutron gateway nodes. For storage, it depends on the back end, but you'd use things like RAID for local disks or replication features in distributed storage like Ceph to ensure data isn't lost if a drive or even a whole server fails.
Protecting the data.
And for the compute nodes themselves, OpenStack has features like live migration. You can move a running VM from one physical host to another for maintenance or if a host is failing without the user even noticing.
Moving running VMs. That's clever.
Very. And the whole architecture is designed for horizontal scalability. If you need more compute power, you just add more compute nodes. Need more storage. Add more storage nodes.
Scale out, not just up.
Precisely. Add more units as needed to increase capacity and also improve resilience.
Okay, so you've planned it, you've deployed your multi-node HA OpenStack cloud, maybe using Juju and NES. What's the ongoing management like, the day-to-day stuff?
Right, the operational lifecycle. People often talk about day 1 and day 2.
Day 0, 1, 2.
Day 0 is the planning and design phase we talked about. Requirements, architecture, hardware selection.
Okay.
Day 1 is the initial deployment and configuration, getting OpenStack installed and running. And again, this is where tools like MAAS and Juju can make a huge difference, automating that potentially complex day 1 setup.
Right, the Canonical tools help here.
Then comes day 2, That's everything else. Ongoing operation.
Well, long haul.
Exactly. This includes continuous monitoring, watching performance, health checks, resource utilization, logging, collecting, and analyzing logs for troubleshooting. Performance tuning, capacity planning for the future, applying security patches and updates, regular backups, obviously, and managing upgrades to newer OpenStack versions.
Sounds like a lot to keep track of.
It is, which is why automation is key, not just for day one, but especially for day two. Tools like Ansible, Puppet, Chef, and Juju are often used to manage configurations, apply updates, and automate routine tasks across the whole cloud.
Automation is essential for sanity.
Pretty much, yeah, especially at scale. You also need solid monitoring and logging systems in place. Things like Prometheus, Grafana, Elasticsearch, Kibana are common. And you need a well-defined strategy for handling upgrades, which, as we noted, can be complex. Canonical puts a lot of effort into documenting and tooling their upgrade paths.
Okay. We've definitely dug into the technical side. Let's pull back again. Big picture. What are the main pros and cons of going with OpenStack, if you had to summarize?
Sure. On the positive side, the big ones are it's open source and vendor neutral. That gives you freedom, flexibility, avoids lock-in.
Freedom, okay.
It's highly customizable and modular. You can really tailor to your specific needs, integrate it with other systems, only use the bits you want.
Customization.
And it has a strong, large, active community behind it. Lots of innovation, support forums, documentation, events.
Community power. Got it. Downsides.
On the other hand, it can be complex. Deploying it correctly, and especially operating it efficiently day-to-day, requires significant expertise.
Complexity and skills needed.
Finding people with deep OpenStack skills can sometimes be a challenge in the job market.
The skills gap.
And, historically at least, upgrades between major releases could be challenging and disruptive if not planned and executed carefully, though tools like Juju aim to mitigate that.
Upgrades can be tricky. Okay. Seems like a fair summary. Despite those challenges, though, we heard some examples. Where else is it really shining? Can you give a few more concrete use cases?
Definitely. We mentioned the telco, NFV, and enterprise private cloud quite a bit. Academia uses it a lot for research computing. Dev test environments are another common one, giving developers self-service access to infrastructure.
Right.
Looking at some of Canonical's case studies gives more flavor, too. Like SBI Bits, a financial tech company in India, uses Canonical OpenStack for business continuity and just getting more efficient resource deployment.
Finance, okay.
Epicensor, an Irish company working on sustainable energy tech, uses Ubuntu Core, which is related, managed potentially via Juju as the foundation for their IoT devices.
Energy and IoT.
Even the European Space Agency, ESA, uses Canonical's infrastructure solutions, likely involving OpenStack or Kubernetes managed by Juju, for supporting space missions.
Space missions, cool.
Screenly uses Ubuntu Core and Snaps, managed infrastructure, for their large fleet of digital signs. Interana, a data analytics platform, relies on Canonical for stability and security. Microvision uses an OpenStack private cloud for autonomous driving development.
Autonomous driving.
University of Tasmania for AML supercomputing. And BT Group, the big UK telco, is working with Canonical, probably using Charmed OpenStack and related tools for their next-gen 5G rollout.
Wow, okay. That's a really diverse range, from finance and space to energy and telco.
It really shows the flexibility of the platform.
So, final comparison point. When an organization is weighing their options, OpenStack versus, say, VMware's full suite, or maybe hybrid options like Azure Stack or AWS Outposts, what are the key trade-offs there?
Good question. VMware, as you said, it's mature, feature-rich, widely used, but it's proprietary. Comes with licensing costs, and you're in their ecosystem.
Proprietary versus open.
Yes, exactly. Azure Stack and AWS Outposts are interesting. They bring the public cloud experience into your data center, but they are very much extensions of Azure and AWS, respectively. You're tightly integrated with and somewhat locked into that specific public cloud vendor.
So still a form of lock-in, just hybrid?
Kind of, yeah. OpenStack offers that more open, customizable alternative for both private and hybrid clouds. If your top priorities are control, avoiding vendor lock-in, maybe leveraging existing diverse hardware, data sovereignty, and you prefer open source, then OpenStack is a very strong contender.
But you need the skills to manage it.
You need the skills, or a partner, or a distribution like Canonical's that aims to lower that barrier. It really boils down to an organization's specific needs, existing tech, in-house skills, and strategic goals. There's no single best answer for everyone.
Makes sense. And looking ahead, what's next for OpenStack? Where is it heading?
Well, the project keeps evolving. Regular 6-month release cycles bring new features and improvements. There's always a focus on making it easier to operate, more scalable, more secure.
Continuous improvement.
A really big trend is the tighter integration with Kubernetes. Projects like Magnum let you deploy and manage Kubernetes clusters on OpenStack. Zun lets you run containers directly alongside VMs. So OpenStack becomes a unified platform for both VMs and containers.
VMs and containers on one platform. That's powerful.
Definitely. There's also a lot of work going into supporting edge computing use cases, smaller, distributed OpenStack deployments, and enhancing its capabilities for AI and machine learning workloads, which often need specific resources like GPUs or lots of data bandwidth.
Adapting to new trends like edge and AML.
Exactly. Staying relevant.
Okay, so bringing this all home, is OpenStack the right choice for everyone thinking about cloud? What are the final crucial takeaways for you listening?
I'd say the main takeaway is OpenStack is a powerful, incredibly flexible platform. But it's not, a simple appliance you just plug in.
Not plug and play.
Right. It generally requires a real commitment, either building in-house expertise or working with a vendor or partner. But if your organization really values deep control, customization, avoiding lock-in, and you have or can get the skills, then OpenStack, especially implemented with something like Canonical's approach using Juju and MA to streamline things, presents a really compelling path for building your cloud on your terms.
Your cloud, your terms.
Yeah. The key is do your homework. Really assess your specific needs and constraints. Be honest about your team's capabilities. Choose a distribution, and we've highlighted Canonical as a strong option that focuses on operations. And really plan for day 2, the ongoing management. That's critical.
Solid advice. So as you, the listener, think about your own tech landscape, your own infrastructure needs, does this idea of a truly open, adaptable cloud built to your specs spark exciting possibilities? Or does it maybe raise more questions about the effort involved?
It's a question worth pondering.
Absolutely. The deep dive definitely continues in your own exploration. We've charted the major constellations of OpenStack today, particularly through the Canonical lens, but there's a whole universe of detail out there. The maps for your own journey, things like the official OpenStack website, Canonical's resources, they're out there ready for you to explore further.